Hello everyone, welcome back to our channel. In the last tutorial, we discussed about method overloading and method overriding with real life example as well as practical example, right? In this tutorial, we are going to discuss about polymorphism and types of polymorphism. And to understand the concept of polymorphism, you should know the basic knowledge about method overloading and method overriding. That already I have explained in previous tutorials, and link I have mentioned in the description of this video. So before coming to this tutorial, first you should go through that tutorials. Okay, now let's begin. And these are the points that we are going to discuss. What is polymorphism with real life example? Then we will see types of polymorphism. There are two types of polymorphism: compile time polymorphism, and it's also called as static binding and early binding. So why it's called as static binding or early binding, all we are going to discuss in this tutorial. Okay, and another type is runtime polymorphism, and it's also called as dynamic binding or late binding. Okay, and all these points I will cover in this tutorial, so keep watching till end. So first we are going to discuss about what is polymorphism. We know that Java is an object-oriented programming language, and hence in Java everything is related to an object. Similarly, polymorphism is also related to an object. So how it exactly related to an object? Let's understand. We know that in this world everything is an object, right? So human is also one of an object, and each object has its own characteristics and actions. Okay, so characteristics of human might be color, height, and so on, and the actions of human, suppose eating, walking. Okay, so let's think about eating. So eating is one of an action of human, right? So if we think, we can eat a food by two ways. That is, if food is solid, then we need to chew it by teeth. And if food is liquid like juice or milk, then we need to swallow it, right? That means we can eat a food either by chewing or by swallowing, right? So in both the cases, action is same, that is eating, but the ways of eating are different. So here action is same, but the ways are different, and it's nothing but the polymorphism. Similarly, in Java, sometimes object has to perform same action in a different ways. Such as, let's take an example of method overloading, because method overloading is the best example of polymorphism. Let's understand through it. Okay, now see here, this is the example of method overloading that already we have discussed. So here there is a class test, and there is one method add value that takes two number of parameters, and the job of this method is to perform addition of two integer values. And there is one more method, and the job of this method is perform addition of three integer values. Okay, so if we notice here, both the methods have a same name, right? But the ways of doing addition are different. Okay, because this method is going to perform addition of two integer values, and this method is going to perform addition of three integer values. Okay, so in both the cases we are doing same action, that is addition, but the ways of addition are different, or we can say action is same but the ways are different, and this concept is nothing but the polymorphism. Okay, so basically polymorphism is a concept that allow us to perform single action in a different ways. Or we can define polymorphism in another way. Okay, now see here, poly means many and morph means form or behavior. Now see here, this method takes two integer values as an input, right? And this method takes three integer values as an input, right? So the input of this method is different, and hence this method will behave differently based on its input, right? And the input of this method is also different, and hence this method is also behave differently based on its input, even though the method name is same. Okay, that means action is same, that is addition, but the behaviors are different, that is single action can have different behavior. Okay, or we can say single action can have many behaviors, and the meaning of polymorphism itself is many behavior. So basically, polymorphism is a concept in which single action can have many behaviors. So either you can define polymorphism like this, or you can define polymorphism like this also. Okay. So both the definition of polymorphism is valid. Okay. Let's take one another example, and it's example of method overriding that already we have discussed, because method overriding is also one of an example of polymorphism. Now see here, there is one method in a parent class that is in a vehicle class, and it's a apply paint. And same method I have override in a child class that is into a car class. So if we notice here, both the methods have a same name, right? But the implementation, or we can say the definition of both the methods are different. So here action is same, that is apply paint, but the ways are different, or we can say behaviors are different, and it's nothing but the polymorphism. Now let's move on the types of polymorphism. There are two types of polymorphism: compile time polymorphism and runtime polymorphism. Okay, so compile time polymorphism is also called as static binding or early binding, and runtime polymorphism is also called as dynamic binding or late binding. Okay, and the best example of compile time polymorphism is method overloading, and the best example of runtime polymorphism is method overriding. Okay, so let's understand what is compile time polymorphism and what is runtime polymorphism. Okay, and we all know that in Java, when we run the program, then first it get compiled by the help of compiler, right? And then it get executed by the help of JVM. So basically, some issues of a program resolve at compile time, and some issue resolve at runtime, such as in method overloading, which overloaded method has to be invoked for a given method call is decided at compile time by compiler, and hence it's called as compile time polymorphism. Similarly, in method overriding, which method has to be invoked for a given method call is decided at runtime by JVM, that is Java Virtual Machine, and hence it's called as runtime polymorphism. Okay, so how it exactly work, let's understand practically. So first we are going to see how compile time polymorphism work, and then we will see how runtime polymorphism work. Okay, so for that, first let's understand what is compile time polymorphism. Okay, so compile time polymorphism is a type of polymorphism in which method calling and method invoking done by compiler at compile time. Okay, so what is it exactly? Let's understand with the help of an example of method overloading, because we can achieve compile time polymorphism through method overloading. Okay, so here I am taking an example of method overloading that already we have discussed in method overloading tutorial. Okay, now see here, I have created here one test class. Okay, and create multiple add value methods with different parameters. Okay, so basically multiple methods having the same name but different parameters, it's nothing but the method overloading. Okay, so these are the overloaded methods. Okay, now I am going to call these overloaded methods, but before that let's create an object to call these methods. So let's create an object inside a main method. So let's create an object of a test class inside a main method that already I have created. Okay, and in Java we must put executable code inside main method, because compiler start execution of a program from main method. Now see here, t is the object reference that pointing to the test class object. If I write here t dot add value, okay, and we know that any program in a Java first get compiled through the compiler and then get executed through the JVM. Okay, so at the time of compilation, when compiler came across this line, then first compiler will check for the reference type, and t is a reference of test type, right? So compiler check for this method in a test class, because we have called this method using test type reference, and hence compiler will check this method in test class. But the problem is that there are multiple methods are available in a test class of a same name. Then question comes that which method get invoked. So in this situation, compiler check for the parameters of a given method call. Okay, so here the parameters is of integer type. Then the compiler look for the method that will match to this parameter and will invoke this method. And if compiler won't find such a type of method in a test class, then the compiler will raise an error and program won't compile. Okay. So in this way, compiler invoke the overloaded methods on the basis of method signature, that is on the basis of method name and number of parameters and their types at compile time, and hence JVM doesn't need to check it at runtime. So basically, compiler decided or resolve which method has to be invoked for a given method call at compile time, and hence it's called as compile time polymorphism. Okay, so simply keep in mind, in method overloading or in a compile time polymorphism, method calling and method invocation done by compiler at compile time. Clear? Similarly, if I write t dot add value, okay, so when this method get called, then this method get execute and we will get the output. Okay, so the here output will be 9. Okay, so let's check it out. Now let's run the code. Now see here, the output is 9. Okay, and if I write here t dot add value, and this method takes float type of parameters, then same compiler will check for this method in a test class. Okay, so there is no method is available in a test class that will take this float type of parameters. Okay, so in this case the compiler will raise an error and program won't compile. Okay, so let's check it out. Now see here, compiler raise an error. The method add value in a type test is not applicable for the argument float. And compile time polymorphism is also called as static binding or early binding. So why it's called as static binding or early binding, let's understand. But before that, let's understand what is binding. So binding means to link or to connect method call to its method definition. So here this is method call and this is method definition. That is when this method get called, then this method get invoked. Okay. So basically, linking or connecting method call to its method definition is called binding. Now let's move on. Why it's called static binding? So static means fixed, right? So in compile time polymorphism, method calling and method invoking done by compiler at compile time, right? That means binding between method call and method definition creates at compile time. That is, binding is already fixed and hence JVM doesn't need to check it at runtime because it's already fixed, and hence compile time polymorphism is also called as static binding. Now let's move on why it's called as early binding. So it's called as early binding because binding is creates at compile time. That means binding is creates before the execution, right? Because compilation always occur before the execution. So basically in compile time polymorphism, binding is creates earlier of program execution, and hence it's also called as early binding. Clear? So simply keep in mind, method overloading, compile time polymorphism, static binding and early binding. All the concepts are same. That is, the meaning of all the concepts is same, but their wordings are different. Clear? Now let's discuss about runtime polymorphism. And runtime polymorphism is quite tricky. So listen carefully. And runtime polymorphism is achieved through method overriding. That means method overriding is the best example of runtime polymorphism. So first let's understand what is runtime polymorphism. Okay. So runtime polymorphism is a type of polymorphism in which method invocation is done by JVM at runtime. Okay. So here I repeat, runtime polymorphism is a type of polymorphism in which method invocation is done by JVM at runtime. So what is it exactly? Let's understand with example. Okay. And for that I am taking same example that already we have discussed in method overriding tutorial. Okay. Now see here, I have created here one parent class, it's a vehicle class, and one child class, it's a car class. Okay, and car class extend vehicle class. Okay, and create one method apply paint in a parent class. Okay, and this method, this parent class method override in a child class. So here implementation or definition of this method is different, applying white color paint to the vehicle. Okay. And the definition of this method is also different, applying red color paint to the car class. So basically method overriding means to redefine parent class method in its child class. Okay. Now let's create an object of parent class that already I have created here. Okay. So if I write v dot apply paint. Okay. So here which method get execute? Obviously vehicle class method will get execute because here v is a reference of vehicle type, right? So at the time of compilation, compiler will look for this method in a vehicle class. If this method is available in a vehicle class, then code compiles fine. And if compiler won't find this method in a vehicle class, then compiler will raise an error. Okay. And at runtime, JVM will create vehicle class object and will invoke vehicle class method and we will get the result. Okay. Now let's check it out. Let's run the code. Now see here we got an expected result. Okay. And if I create child class object, so car, okay, and if I write c dot apply paint, okay, then which method get execute? Obviously child class method, that is car class method, will execute. So let's check it out. Now see here the output is applying red color paint to the car. Now see here, if I use vehicle class object reference to hold car class object, that is v equals to new car. Okay, so here v is a vehicle class object reference that hold the car class object, right? And if I write here v dot apply paint, now see here we have called this method using vehicle class object reference, right? But vehicle class object reference is pointing to the car class object. Okay, now question comes that which method get invoke or which method get execute, vehicle class method or car class method? So if such type of situation create, then let's understand what is the job of compiler and what is the job of JVM. Okay, so listen carefully. So at the time of compilation, compiler will check reference type. So here v is object reference of vehicle class and hence compiler will check this method in a vehicle class. If this method is available in a vehicle class, then code compiles fine, and if not available, then will raise an error. So always keep in mind compiler always check the method based on reference type because compiler is unaware about object that going to create because object creation takes place at runtime after the compilation. That means compiler aware about this part only and unaware about this part because the new keyword is used to create an object and object creation takes place at runtime. That's why compiler aware about only reference type and hence compiler always go through a reference type to invoke a method. Okay, so simply keep in mind in method overriding compiler always call the method based on reference type. So in this case also compiler will check the method using reference type and v is object reference of vehicle class and hence compiler will check the method in a vehicle class. But at runtime, JVM will create car class object and will invoke car class method and we will get the output. So in this case, method invocation done by JVM at runtime and hence it's called as runtime polymorphism. Clear? So basically in runtime polymorphism, method invocation is resolved at runtime through JVM. Hence it's called as runtime polymorphism. So in this case car class method get execute because here runtime object is of car class. Now let's check it out which method get execute. Okay. Now see here the output is applying red color paint to the car. So in this way JVM is responsible to invoke the method at runtime and hence it's called as runtime polymorphism. So remember one thing, compiler always go through reference type to resolve the method invocation And JVM always go through object type to resolve the method invocation. Clear? And runtime polymorphism is also called as dynamic binding or late binding. And we know that what is binding, that already we have discussed. So dynamic means at runtime. So the binding that creates at runtime, it's called as dynamic binding. Okay. Now let's move on why it's called as late binding. Because in a runtime polymorphism, binding between method call and method definition occur at runtime, later the compilation, and hence it's called as late binding. So simply keep in mind, in compile time polymorphism, method invocation resolve at compile time through compiler, and in runtime polymorphism, method invocation resolve at runtime through JVM. Okay. So remember, in Java programming, compiler always deals with method overloading and JVM always deals with method overriding. Okay. So in this way, we can achieve compile time polymorphism and runtime polymorphism through method overloading and method overriding. That's it. This is the basic of what is polymorphism, what is compile time polymorphism and how it work, and what is runtime polymorphism and how it work. And for more help, you can refer my notes that I have mentioned in the description of this video. Now I am going to end this session. So keep learning, keep growing, and thank you so much for watching.